Let's begin section 1 with some vocabulary. I'm going to be using some of these examples of patterns at the top. Instead of calling them patterns, from now on I'm going to refer to an ordered list of numbers as sequences. We studied 4 sequences at the beginning, and each sequence had something different, a different sort of way of making the future terms of the sequence. I've used the word term just in that last sentence. A specific term is one of the numbers within a sequence. So if I wanted to ask you, what is the 4th term of the first sequence? 1, 2, 3, 4. That 4th term would be 9. Now, if I know the place in the sequence, I can refer to it by name, like here's the 4th term. Here's the 6th term of the same sequence, etc. If I have a term that's in the sequence, but I don't know where it is in its location, we call this the nth term. There's some notation that we're going to be using later. N is the location of the term in a sequence. If I refer to, like in the first exercise, if I refer to 1, 2, 3, 4, the 4th term, I'm going to write an A with a subscript 4, which means this is the value of my term. In the 4th position, its value equals 9. When we talk about an nth term, we're talking about a term whose location is not known. So n is a variable. In order to find a specific term, we need a formula. Part of what we will do in this lesson is to create formulas for patterns once we discover what type of pattern it would be. Down below, we have 1, 2, 3, 4, 5, 6. We have 6 exercises where we have to come up with the next terms in each pattern or sequence. In order to do this, we just have to remember that terms are located first or second or third in order, and that's what gives you the value of n. N is the location in each sequence where a term is found. If I don't have a sequence laid out with me like we did in our warm-up, but I do have formulas for them, what I can do is generate the sequence by plugging in values of n. Starting with our first one. Now here's the pattern defined as t of n. So a term in the sequence that's nth in its place is 7n plus 8. In order to find the first term, t sub 1, I'm going to substitute the value of 1 in place of the n. Next, I'll evaluate using order of operations. 1 times 7 is 7. 8 more than 7 makes 15. So the value of my first term, t sub 1, equals 15. The value of my second term, t sub 2, is 7 times 2 plus 8. After doing at least maybe 2 or 3 terms, maybe we can do like what we did in the warm-up and guess the next 2 without evaluating our formula. Let's evaluate this one though using order of operations. 7 times 2 is 14. 8 more than 14 makes 22. What do you notice between term 1 and term 2? Do you notice that it's increasing? Let's evaluate term 3 the same way we did, terms 1 and 2. Plug in the value of 3 because 3 is its location, its third in place in order of the sequence. The value of the third term is 7 times 3 plus 8. 21 plus 8 makes 29. Okay, now I'm sure I know what's going on. Pause the video and see if you can come up with the next 2 terms in the sequence. Each term is 7 more than the previous term. It looks like that might be because our slope is 7. I'm calling it slope because it's a constant rate of change of increase of 7. So what were your next 2 terms? 7 more than 29 is 36, and 7 more than 36 was 43. This gives you term 4 and term 5, or t sub 4 or t sub 5. Going across to exercise 2, we'll take a look at this pattern and see how we can generate the first 5 terms doing the same thing we did in exercise 1. Let's plug in the values 1 through 5 to get each term. I'm just going to do a random term in the sequence. I'm just going to start with the 4th one. It's not necessarily random, but just any term can be found using this formula. First, I need to square the value of n, which in this case is 4 for the 4th term. I'll square that to make 16. Then I'll minus 3 times that value, or 12, 3 times 4 is 12, and do the subtraction. The fourth term is 4. I'll just do another one. Term 2, our second term, 2 squared is 4. And 3 times 2 is 6. 4 take away 6 is negative 2. Go ahead and find the other 3 terms. You may pause the video now. The value of your first term, if I plug in 1, would be negative 2. The value of our third term would be 0. And the value of our fifth term would be 10. Question 3. Now this formula also looks familiar to me. When we studied exponential growth and decay, we noticed that there's an original amount, or an initial amount, and there's a growth factor. I'm expecting this to behave like warm-up question number 3, where there's some initial amount and it's going to decrease. Let's see if that's true. Let's do the same thing to generate our sequence, starting with plugging in the value of 1. First thing order of operations says to do is evaluate this exponent. 1 minus 1 is 0. Any base to the 0 is 1, and 16 times 1 makes our first term 16. Start off by doing our second term. T sub 2 has a value of 2 for n. 2 take away 1 is 1. 1 half to the first power is a half, and 16 times a half, that makes 8. Go ahead and find the values of the third term, the fourth term, and the fifth term. You may pause the video now. Did you get 4, 2, and 1? Nice job. We were correct in thinking that this is an exponential decay situation. Each term is half of the previous term. Half of 8 is 4, half of 4 is 2, and half of 2 is 1. So the previous term would be the term to the left, and we're going to be using the terminology of term and previous term later when we write a recursive formula in section 3, but let's not get too ahead of ourselves. Exercise 4. Exercise 4, we're going to evaluate and write a sequence for this pattern. Let's take a look. Let's plug in 1. I get negative 3. Let's plug in 2. Then I'm subtracting. I raise negative 2 to the first. I get negative 2 times positive 3 is 6. Let's try again. Let's find the third term. Plug in 3. Take away 1 is 2. Negative 2 squared is positive 4. And positive 4 times negative 3 is negative 12. It looks like the next term is the previous term times negative 2. So I can quickly finish this one off because I evaluated enough terms for me to understand what's happening in the sequence. The last 2 exercises at the bottom you can try. I'm going to pause the video, and so should you, and finish this up. Alright, let's take a look. What did you get for each of these? 1 cubed times negative 2, 2 cubed times negative 2, 3 cubed times negative 2, 4 cubed times negative 2, 5 cubed times negative 2. These should be the terms in your sequence. And our last exercise. This reminds me of number 1. We're going to decrease by 4. Let's plug in 1 first. It looks like I got negative 36. Decrease by 4, negative 40. Decrease by 4, decrease by 4, and decrease by 4. If you're having trouble with the last 2, then you can go back to evaluating them term by term and plugging in for your formula. I think we did a great job with the first section. We're going to now close this video, and maybe you should open section 2. And best of luck.